Let's talk about nucleophiles and electrophiles. So hopefully you guys are familiar with the archetype of how reactions go down in organic chemistry. You have some element A is going to go attack element B, let's say for example, right? And you end up with AB, right? Hopefully this is very familiar to you guys right now. And so we're going to do a quick review on nucleophiles and electrophiles. So essentially, the thing that's going to be attacking, in this case, A, is going to be considered the nucleophile. A. So in this schematic right here, this little archetype, A, the nucleophile is going to be attacking things. And how do you identify a nucleophile? Well, I'm glad you asked that question in your head, hopefully. But nucleophiles are going to be things that are going to be attacking. Yeah? You can usually identify them because of the very first obvious thing that makes something a nucleophile is if it's negatively charged. If it's got a negative charge, it is going to go and attack. Now, that's usually true most of the time. And for other scenarios, right, maybe there's no negative charge there explicitly, but there's lone pairs in place there. Yeah, if you see a lone pair, most likely that thing's going to be, probably could be a nucleophile. And, doing the attacking. And so the main kind of rule that wraps up how you identify nucleophiles is that they have what's called electron density. Electron density. Yeah, they have an abundance of electrons that they can use to go and do chemistry. Yeah, so electron density. So they either have a explicit negative charge or they have lone pairs. And that makes sense, right? If you have an excess of electrons, right, they either show up, manifest themselves as negatively charged, right? Because when something's negatively charged, it generally tends to have more electrons, and lone pairs. Yeah. So electron density. So what about electrophiles? Well, electrophiles in the schematic that we drew down here are going to be the ones B. Yeah, things that are going to be attacked. And if nucleophiles, right, are electron dense, then electrophiles are going to be electron poor. And these guys are being attacked. Yeah? The most obvious sign of something being electron poor, right, is probably going to be a plus charge, right? That's the opposite of a negative charge. So you're going to have a plus charge. And you're also going to have situations, right, where the plus charge isn't obviously going to be explicit. But luckily for you, hopefully everyone here recognizes electronegativity, right? Or EN. EN. Electronegativity. And essentially, electronegativity is the tendency of an element to pull electrons towards itself. Hopefully this was hammered into your head in Chem 8A, or just the general chem series as well. And so we recognize that there's a bromine here, a chlorine here, and an oxygen here. And all three of these are very pulling electrons this way. Pull electrons from something, right? It means that something that you're pulling from is going to be positively charged, yeah, or have some sort of positively charged character. So yeah, that's how you recognize, like, it's either have and it. Okay. Now, if you're confused between nucleophiles and electrophiles, right? If you confuse the two a lot, right? One of the tricks that I like to use that the word nucleophile, right? Nucleophile. Nuke reminds me of the word nuclear. I cannot spell. Nuclear weapon. Very morbid. And to my credit, I don't, hopefully, we don't have nuclear war in the future. I'm crossing my fingers really hard here. But this is a vivid example. Psychology shows that vivid examples kind of stick into your head. And so, right, what do you do with nuclear weapons? Well, they're made to be launched to attack things, right? And so nucleophiles are going to be the ones doing the attacking. If you want, just imagine every single time you're doing a reaction, you're like launching nukes, that would probably stick into your head. So that's basically the rundown, the basics let's do some practice problems. I want you to stop the video and try to do these on your own. Identify which one's going to be the nucleophile, which one's going to be electrophile. So let's start off with this example right here. Yeah. So this bad boy right here, we got a bromide, yeah, and we got a carbonyl, right? So obviously, right off the bat, negatively charged, that's going to be the nucleophile, right? Because it has an abundance of electrons. It's going to be the one doing the attacking, and then we have electrophile over here. Right. Once you kind of figure out what's the nucleophile or which one's the electrophile, I mean, it's basically process elimination from there. You only have two options, right? So one must be the other, right? But this is a nucleophile because you have, right, a negative charge. And this is a electrophile because you have an O here. O is very electronegative. It's going to pull it this way. And you're going to have a partial positive charge here on this carbon right here. Therefore, it's going to be the one most likely to be attacked. Okay. You have this example over here, right? Now we have two interesting examples that are popping up here because it's not entirely obvious, right? Which is going to be attacked, which is going to be attacking. Both of them have lone pairs in some capacity, right? But if you look very carefully, right, this is basically the same structure that we drew up there, right? But this bromine right here, right, is going to be electronegative. So it'll be pulling a plus charge, pulling electrons towards itself, and therefore the carbon that is next to it is going to be positively charged. Yeah. Now this oxygen over here is very also electronegative as well, but there's no electrons for it to pull from, right? Because it's surrounded by two hydrogens. Hydrogens don't really have a lot of electrons to pull from. And so regarding that, right, this is going to be your nucleophile over here. Yep. This is going to be your electrophile. Another cool tip too is that basically if you see literally like any of the halides, or sorry, halogens, yeah, halogens, so like Br, F, Cl, if you see them attached like in this manner, right, to an alkyl group, right, which is a group of just carbons, anything like that, most likely going to be an electrophile. Okay, cool. And so let me give myself some space here. As you guys know, I'm the CEO of running out of space. So this one's a little interesting, right? But hopefully, as you guys can see the pattern by now, right? This O and the Cl, right? They are going to be pretty electronegative. They're going to be pulling this way, and therefore this carbon right here is going to have a partial positive charge because of the electronegative atoms that are pulling in their direction. And this NaSH over here, hopefully you guys remember, right? But when you take any of the metals that are on the far left side of the periodic table, we're talking lithium, sodium, potassium, right? You take those and you attach them to take sodium, right, or any other metals that are in that same area, and you attach it to a non-metal. What's going to happen is that you're going to form a compound that if you throw it into water, it's going to dissociate. So you're going to get Na plus and SH minus. Now we've made things very easy for us now, yeah? So this Na plus, right, is not actually going to do anything. It's going to be called what's called a spectator ion. It's going to go off on a fun vacation to Spain, just sit and watch. And the SH is going to be the one doing the work. And hopefully this look a little bit more like something that we saw on the chart earlier, yeah? So this is definitely going to be a nucleophile, right? Because it has a negative charge, electron density, yeah? This is going to be electrophile over here, process elimination. Also because you have Cl and O around it, yeah? Okay, let's move on to our last example. This one's a little bit less obvious. If you're keen-eyed and you have a pretty good memory, you remember this from 8A. But essentially, right, in the contrast between these two, and if you haven't tried to solve this on your own yet, I highly recommend you do it now to exercise your brain. But remember what I said that nucleophiles are electron dense? Well, if you have a double bond, it naturally kind of means that you have more electrons, right? And this is actually, I believe, this is halogenation, yeah? No, hydrohalogenation. I believe that's the correct term. I mean, you can correct me in the comments. I mean, this is not really important. It's from 8A, so like, you know. But this is, yeah, so essentially the end product is that you are going to form Cl and H attached to this thing. And therefore, this guy over here is going to be a nucleophile. Electron density, yeah? And here's your electrophile. It's going to be the one attacking here. Okay. Hopefully that was helpful. Good luck studying, and hopefully the rest of your day goes well. All right, see you in the next video.